When we have integrals in the form of 1 over a squared plus x squared, we can now use that as a standard defined integral. And that integral is going to look like this. It's going to be 1 over a arctan x over a plus c. And when we have the integrals of the form 1 over square root of a squared minus x squared, that is an arcsine form. And we're going to put it into arcsine x over a. So that this general form here has an extra a in it, so we can accommodate factors other than just 1. So for the arcsine form, just be careful because x over a has to be less between negative 1 and 1, okay, because that is our ratio in the triangle. We have to make sure that x is either bigger than negative a or less than positive a to keep that in the correct domain. Okay, so taking a look at example 1, that is, we need to recognize that this is not a standard integral that we've known before. This is a standard integral form of the arcsine. So integrating this, we're going to use the formula. So looking at the formula here, I should recognize that 4 is a squared. Okay, so the a squared is equal to 4, which makes our a value equal to 2. So integrating this, I'm going to take the 5 out. It's going to be arcsine x over a, which is 2. And then since this is a definite integral, it's going to be from 1 to root 3. So there it is. There's my integral. I can now evaluate that integral. It's going to be 5 over arcsine. I'm going to plug in our root 3 for x, then minus the arcsine of 1 over 2. These are exact values. Okay, just remembering our circle. So root 3 over 2, arcsine, remember that it's only defined in these quadrants, so I can only use those angles. So root 3 over 2 is going to be our 60-degree angle. So root 3 over 2. So that's going to be 3 pi over 3 radians minus, when the sign is 1 over 2, that's going to be in this orientation here. That's going to be 1 over 2 like that. So that's going to be our 30 degrees, or pi over 6. So then when we work this out, pi over 3 minus pi over 6 is going to be pi over 6. So our final answer is going to be 5 pi over 6. And that would be the displacement on that function from 1 to root 3. For example 2, this does not look like an arctan form, but it is. Now, with most quadratic polynomials in the denominator like this, we could try substitution, but in this case, there's no substitution that works. So at this point, we're kind of stuck. We could try factoring. If it's a perfect square factor, that would be okay, but in this case, again, it doesn't factor a perfect square factor. So at this point, unless we have some other thing that we can point to, we can't really do anything. And the other thing in this case is, the thing that we can point to is, maybe I can put this into the arctan form. And what that's going to involve is this quadratic going to have a negative discriminant? Okay, if it does, that's going to fit our arctan form. So I'm going to test my discriminant here. B squared minus 4ac, that's going to be 2 squared minus 4 times a times c. When I work that out, it's going to be 4 minus 68. And the fact that it's negative means that this has non-real roots. Okay, so it's got non-real roots. So if we have a quadratic in the denominator with non-real roots, we're going to be able to put this into the arctan form, and it looks like this. So if it has non-real roots, what we want to do is put it into an a squared plus x squared form. Well, that x squared can also have a horizontal shift in it. And we're going to do it so that we end up with a perfect square factor. So to do that, we're going to take part of this expression and complete the square. So I'm going to take x squared plus 2x, and I'm going to do plus 1. And that's going to complete my square. That's also going to leave an extra plus on from that 17. So it's going to leave an extra plus 16. And notice that when I put this into the perfect square form, we end up with x plus 1 squared plus, this is really just 4 squared. Well, that is the arctan form with a horizontal shift. It's just something squared plus something squared. Well, that is where I can use arctan. So then I can just put it into the formula. So the integral of this is going to be equal to 1 over a. Well, a in this case is 4. Okay, since a squared is 16, a is 4. Arctan, the x has a horizontal shift, so we just have to make sure we keep that when we integrate it. So it's going to be x over x plus 1 over a, which is 4, and then plus c. So there it is. We have anti-differentiated that expression. And the key is, with these quadratics in the denominator, if they have non-real roots, we can rearrange them so that we have a perfect square part plus another square, and that in the denominator, which then we can apply the arctan formula for.